Welcome to day 6. Homework for tonight is page 31 and 32. Problem set is due next class period, so make sure to finish that if you haven't done so yet. And today's the last day of new material. So for your warm-up, we want you to find both the value of x and y. And note we have a right triangle where we know 2 of the 3 sides. So you should be able to do that by using Pythagorean theorem. So we are going to pause the video for 3 minutes to make sure you have out your homework. So that'll be ready to go when we get there. Have your warm-up sheet out, and you can give this warm-up a try. Again, we'll pause for 3 minutes. So we should have got that x was 15. Now, when you went to set up for y, you should have noticed it was the exact same Pythagorean theorem, so y would have ended up being 15 as well. So you can put your warm-up sheets away. Our purpose for doing that we'll come back to as part of today's lesson. It'll tie into that. If we go over to our homework, you had some perpendicular lines implies right angles. Right angles implies congruent angles. Midpoint implies 2 congruent segments. And then we should have used some vertical angles implies congruent angles. Now you could have done those chunks in any order, but you needed those 3 sets of things. I chose to just call my right angles S and Q. You could have numbered them as well. QT and QS, or QT and TS should be the congruent segments from your midpoint one, and I numbered my angles 1 and 2 for the vertical angles. From there, that gave us a side in between 2 angles. So our triangle is congruent by angle, side, angle. I chose to name one of the triangles PQT. If you didn't, you just got to make sure things are matched up in the right spot. So wherever your P is, in terms of first, second, or third, R should be in the same spot, Q and S should be in the same spot, and then the T should be in the same spot. And then lastly, congruent triangles implies congruent corresponding parts, and we've got what we wanted to prove. So your only way you could vary is in steps 4 through 7, you could rearrange like when you did the vertical, when you did the midpoint, when you did your perpendicular and right angles implies. Those could vary, but other than that, this proof should be exactly the same. Going on to number 2, we were given a set of angles and a set of sides congruent already. So that was 2 of 3 things. Then we had parallel lines. If you tried to do a zigzag with the parallel lines, one of the angles of the zigzag was not in the triangles. So that told us to then look for corresponding angles. So it's sometimes helpful if you extend the parallel lines and extend the transversal. Notice this angle is now in the top right. Angle 2, where I numbered, is also in the top right. So we can do parallel lines implies congruent corresponding angles. That gives us that angle 1 and 2 congruent, and now we have a side in between 2 sets of angles for angle, side, angle. When naming your triangle, the A and the B had to be in the same spot, the E and the D, and then the B and the C. And then our last step, we had congruent triangles implies congruent corresponding parts. Going on to number 3, we had a set of angles and a set of sides that were given to us. If you tried to just do reflexive, you would have had side, side, angle, and that would not have worked. Not that the reflexive is wrong, but it wouldn't have allowed you to finish the proof. So we need to use our parallel lines. Do a zigzag that involves your parallel lines. It would be this option here. So the angles of my zigzag I labeled 1 and 2. So we have parallel lines implies congruent alternate interior angles. That now gives us a side between 2 angles, so that's ASA. When naming your triangles, the F and the H have to be in the same spot, and then the G and the J, and then J and G. And then finish off with congruent triangles implies congruent corresponding parts. And our last one, we have a set of angles and a set of sides that were given to us. If you just did reflexive, then you would have side, side, angle, which didn't work. So we got to use our other given there, the angle bisector. Angle bisector sometimes difficult to pick out where it is. So trace the angle or BDF, trace DH. Notice they're meeting at D. So that's where the congruent angles should be. I chose to number them 3 and 4. So angle bisector implies 2 congruent angles. We have a side in between two angles, so ASA. Your B and your F should be in the same spot, the D is in the same spot, and the H is in the same spot. And then we finish with congruent triangles implies congruent corresponding parts. All right, so if we flip over to page 27, our last piece of new material for this unit is we are going to learn a fifth way to prove triangles congruent. So first off, some vocabulary. When you have a right triangle, the angle across, or the side across from the right angle is called the hypotenuse. Okay, I'm guessing most people already know that. The non-hypotenuse sides are called the legs of the right triangle. What this new method is called, it's called hypotenuse leg. And we will abbreviate it with HL. So we'll end up using in our proof HL congruent to HL. And what that means is your hypotenuse and your leg in one right triangle are congruent to the hypotenuse and leg in another right triangle. Hypotenuse leg is a special case of side-side angle. In general, side-side angle doesn't work. But I'm going to flip back to our warm-up here. Notice in our warm-up, the given triangles, we eventually saw that they were really the same by Pythagorean theorem. Well, the given information, we had an angle here with the right angle. We have a side, and we have another side. So we have a side-side angle case that we proved worked because when we did Pythagorean theorem, it showed this other one was the same. So side-side angle will work only when the angle is a right angle. And the reason for that is you could then do Pythagorean theorem to get the third side. Any other type of triangle, Pythagorean theorem doesn't apply because it's not a right triangle. So what today we're going to be working with is we'll work through, if we happen to get side-side angle, if the angle's a right angle, we can keep working to get hypotenuse leg. You should still never put SSA in a proof. If it's the special case, we would use hypotenuse leg. Now really, what's happening here is because we could do Pythagorean theorem, notice we could do this with side, 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 or we could have side, angle, side now. So because of Pythagorean theorem, really the congruence rule we're eventually getting is either side, 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 or side, angle, side. Now we won't have to do it all the way to get those. We'll just be able to say HL congruent to HL. If we go down to the bottom, the three things that we need. We need to have right triangles. You need to have the hypotenuses congruent, and you need to have one of the legs congruent. When we start a proof, we will not be hunting for hypotenuse leg. We will just do our proofs like we normally do them. If once we get three things, if we happen to get side-side angle, we know that doesn't work, but we will check to see is the angle a right angle. If the angle's a right angle, then we'll be able to state that we have a right triangle. On our cards, the last thing we have to look at, the top one there, is right angle implies right triangle. That's where this one's going to come into play. If we find we have side-side angle, which we would never put side-side angle in a proof, if that angle is a right angle, then we'll be able to use right angle implies right triangle and then use hypotenuse leg to prove the triangle is congruent. So it's usually easiest to just see this in action in an actual proof. So let's go over to the next page and we'll do number one and take a moment to do your statements, reasons, and givens. So we are given some things that are congruent, CD congruent to EA. So we'll go ahead and put a tick mark on there. We're already 1/3 of the way of getting our triangles congruent. Our other given is very powerful. Perpendicular bisector. We'll be able to use our perpendicular stuff and we'll be able to do our bisector stuff. So let's do our perpendicular stuff first. We know automatically perpendicular lines implies right angles. Let's see where the perpendicular lines meet. CE and AD are crossing at B. So those two are going to be where the right angles are. I'm going to go ahead and label them 1 and 2. So we can say angle 1 and angle 2 are right. Automatically, we will next do right angles implies congruent angles. And for our statement, we'll be able to just say those two angles are congruent, angle 1 congruent to angle 2. Because we just said they're congruent, we're going to mark them up in our picture. Now it's important, we just said right angles congruent, so instead of doing an arc, we're going to put our box in. Well, now we also have the AD as the bisector of CE. After that word bisector is a segment, so that'll lead us to do segment bisector implies midpoint. And where they cross is B. So we're going to have B is the midpoint of, and it's always of the one that comes after the word bisects or bisector. So we'll have it's the midpoint of CE. Automatically next, we'll do our midpoint implies two congruent segments. If B is in the middle of C and E, that would mean that CB is congruent to BE. And we'll mark those up in our picture with some tick marks. And then let's see what combo of angles and sides we have. Well, we have two sets of sides and one set of angles. Our angle is not in between the sides. If we had the angle in between the sides, it would be angles E and C. So currently we have SSA, which we should never put in a proof. Never, ever, 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 ever should you put SSA in a proof. It's automatically wrong if you put SSA in a proof. The special case of SSA that works is if your angle's a right angle. So notice our angle happens to be a right angle. So we're going to be able to still prove this. Here's what we need to do to prove this. In reason 7, we're going to use our top reason on our card. We're going to say that right angle implies right triangle. And then in the statement, we'll just say the two triangles we're working with are right. So we'll say triangle CBD and triangle EBA are right. So now in the last step, we've got a right triangle now, which allows us to do hypotenuse leg. So you just do the proof normal. If you happen to get side-side angle, check and see if the angle's a right angle. If it is, then you're still okay. You just got to do right angle implies right triangle, and now we can prove the triangle's congruent. And how we prove them congruent is by hypotenuse leg. So we'll say HL congruent to HL, the HL standing for hypotenuse and leg, and then our statement is just what we wanted to prove. Triangle CBD is congruent to triangle EBA. All right, moving over to our next one. Take a moment to do your statements, reasons, and givens. We have a set of things congruent, WJ congruent to KZ. So I'll mark those with a tick mark. We have some right angles. So let's automatically do right angles implies congruent angles. And that would mean that angle W is congruent to angle K. We'll mark W and K congruent in our picture, but because they were congruent right angles, we'll put the box in instead of an arc. And we only have two things right now. We have an angle and a side, but notice they're sharing JZ. So we can do a reflexive property. And we'll have JZ congruent to JZ. And we'll mark that up with an X in our picture. Well, notice currently in each triangle we have two sides. And we have the angle that is not in between those sides. So currently we have side-side angle, which doesn't work. We should never put side-side angle in a proof. But we now, based on what we learned today, want to look at our angle. Our angle is a right angle, so we're going to be okay. So to finish this proof off, we've got to do our right angle implies right triangle, which again is the top one on our card, which we can add into the ones that we're studying from the card now. As our statement, we'll just say triangle JWZ and triangle ZKJ are right. And we'll finish off, we'll now be able to do that our triangles are congruent by hypotenuse leg. So we'll say HL congruent to HL. And our statement will just be what we wanted to prove. Triangle JWZ is congruent to triangle ZKJ. All right, if we look at number 3 now, we'll go ahead and do our statements, reasons, and givens. So we got some things that are congruent. We'll mark up SP congruent to QR. We have some right angles, so let's automatically do right angles implies congruent angles. So that'll be angle PRS is congruent to angle RPQ. When we mark them up, we'll mark them up with a box because they're congruent right angles. PRS would be right here. R was the middle letter. RPQ would be right here. P was the middle letter. We only have two things marked up, but they share something, so we'll do reflexive property. And it'll be PR congruent to PR. We have two sides. The angle is not in between. If the angle was between, it would have been these two angles, which we don't have. So we currently have SSA, which we should never put in a proof. But based on what we know today, look at the A. If the A is a right angle, we're going to be all right. Our angle was a right angle here in our SSA. So we're going to be able to do our top one on our card. Right angle implies right triangle. We'll be able to say triangle PRS and triangle RPQ are right. And because we had SSA, but then we said it's a right triangle, we are good to do hypotenuse leg now. So we can do HL congruent to HL. And that'll be triangle PRS is congruent to triangle RPQ. All right, we'll do one last one in this video. We'll do number 4, so go ahead and do your statements, reasons, and givens. As I'm doing it in the video here, if you're starting to feel pretty comfortable with these, feel free to move quicker than I'm moving in the video. We had one set of things congruent. We had PS and we had PT. We've got our perpendicular lines, so I'm going to do perpendicular lines implies right angles. PR and ST are meeting at R, so I'm going to number those 1 and 2. So we'll have angle 1 and angle 2 are right. And then we're going to automatically do right angles implies congruent angles. So we'll say angle 1 is congruent to angle 2. When we mark them congruent, we're going to put the box in. And now we have two options of where we could go from here. I'm going to go ahead and do reflexive next because they're sharing RP. And we'll do it that way, and then we'll talk about what the other option would have been. So we're sharing RP, so we'll have RP congruent to RP by reflexive. And if I mark that up with an X, notice we have two sides and an angle. The angle is not in between the sides, so we have side-side angle, which we should never put in a proof. But if we look at our angle, it's a right angle, so we're going to be okay. All we've got to do to be able to get the triangles congruent is we've got to first do right angle implies right triangle. So we would have triangle PRS and triangle PRT are right. And then we'll finish this off with HL congruent to HL. And we'll have triangle PRS is congruent to triangle PRT. Now, here's the other way you could have gone. Instead of in step 5 doing reflexive, you could have thought of the big huge triangle, which had two congruent sides. And you could have said triangle STP was isosceles, because two congruent sides implies isosceles triangle. And then you could have done isosceles triangle implies two congruent base angles, which would have given you angle S and angle T congruent to each other. And using those angles along with the right angles in the given, you could have done an angle side. It would have taken the same number of steps, because basically this step would have been replaced with the congruent sides implies isosceles triangle, and this step would have been replaced with isosceles triangle implies two congruent base angles, and then you'd have ASA or angle side for the last one. So same number of steps either way, whichever way you saw it to do it best. That's it for this video. You can work on your homework with any time left in the period, and you also have problem set, which is due tomorrow. Have a great rest of your day.